In this video, we are going to look at physics, alternating current, whereby we're going to focus on what you need to learn in alternating current A-level physics of Cambridge 9702. I'll take you through the main concept that you must know as far as that topic is concerned. So alternating current, you need to understand that is a type of current that keeps on changing direction, periodically changes direction. So current can increase, decrease to zero, negative, move to the negative side. So current, as it's flowing, it keeps on changing direction. So in that process, you are going to have current varying from the maximum value to the minimum value, like that. So in below the x-axis, now current flowing the other direction. So you will find that current, power, voltage is not constant like in direct current. This type of waveform can be represented, can be able to be represented because it looks like a sine wave. It looks like a sine wave there, whereby it has amplitude, which is the peak voltage or peak current. Highest value is, for instance, if you're having this, the peak voltage or the largest voltage, largest current is 2. Highest voltage is this. So you are going to have maximum voltage or maximum current, which is referred to the peak current or peak voltage. Then this value that you shall be having at this point is going to represent the angular frequency. And remember, angular frequency is going to be given by 2 pi f or 2 pi over t. Okay? So meaning you are going to be given questions and you are expected to find the value of I naught. If you are asked to find the value of I naught, then you have to read the maximum value. If you are asked about V naught, you are going to read from the graph the maximum value, and that is the peak voltage or the maximum voltage. If you are asked about period time, remember period is time for one complete cycle. And the frequency is the number of cycles per second. So you have to know the relationship between that. And also you are going to understand the concept of root mean square. Root mean square is the value of direct current that is going to deliver the same power as that particular alternating current. So remember, alternating current keep on increasing and decreasing. So if current increases or decreases, it keeps on fluctuating a given within a given range. Then it means also power is going to be varying, increasing or decreasing. But when you are working out power, when you are doing IGCSE level, you realize that we were applying formulas, power is equal to I squared R. But when you are coming to this now, because power is fluctuating, current or voltage will be fluctuating, you cannot be able to use those values that way. You cannot be able to use the value directly that you are having here. You have to work out the root mean square. And root mean square is the value of direct current that will deliver the same power as that particular alternating current that you are having. So when you are finding root mean square, you are going to take the peak voltage, maybe the one that you read from here, peak voltage or peak current, then you divide that value by root 2. Okay? So that you can be able to have a root mean square, then you can be able to apply them in this kind of formulas. We are going to see an example on the same. So something also we need to understand that for alternating current, power keeps on fluctuating. So the mean power of an alternating current is a half the power of alternating current. If you are told the power of the alternating current is 20 hertz, the mean power, the average power this AC will be giving will be a half of that value that you are given. Now, for instance, if you are told 20 watts is the power of alternating current, if in an exam you are asked the mean power, you will take that value divided by 2. Now, let's look at an example here. An alternating current is connected to a 120 ohm resistor, and the peak value of that alternating current is 25 volts. Calculate the average power. Remember, power is I squared R, but I is V over R. So whatever we have here is voltage. So if we have this voltage here, it will mean that we cannot be able to use this because this is the peak value of alternating current and it keeps on fluctuating. So meaning we need to go ahead and work out the mean, the root mean what? The root mean square, which is going to be a value of direct current that will deliver the same power of this alternating current we are having here. So meaning we are going now to apply that voltage mean, root mean square voltage. It's going to be the peak voltage, which is 25 over root 2, and then you are going to have 17.7. So that is the voltage now you will use in this particular section here, because we are looking for current, isn't it? Current. Maybe we are looking for power. We can be able to apply power V squared over R instead of finding current and then we apply it here. We can just use the voltage that we have gotten here, and then our power is going to be 2.6. The output potential difference of an alternating power supply is represented by this. So we say that alternating current can be represented as I, this is the current at a given instance, is equals to the peak current sine omega t. So this one is going to represent angular frequency. This is going to be the amplitude here, which is representing the peak current. So meaning that if we are going to use this, our peak current voltage, is V0, which is 320. Then determine the root mean square of the PD, means the root mean square of the PD. So root mean square of the voltage is going to be the peak voltage, which is 320 over root 2, and if you work it out, it gives you what? 230 volts. Then we are supposed to find the period of this output. Now, the frequency, angular frequency is 100 pi. So if it's 100 pi, it means now we can say 100 pi, omega is 100 pi, because it's taking the position of this omega position here. Where we are having omega, we are having 100 pi. So which means we are going to say that 100 pi is equals to 2 pi over t, because we are finding the period. So we are going to use 2 pi over t, which will mean that our final answer is going to translate to 0.02 seconds. The power supply is connected to a resistor R, and then we are told that state the name of the type of rectification. You need to understand that rectification is the process of converting alternating current to direct current. So there are two types of rectifications, and that is going to have half-wave rectification and full-wave rectification. So in that case here, we are having one diode. You are going to realize that this type of rectification that uses one diode, it's called half-wave rectification, which we are going to see in this particular part. So which means that alternate current is applied to this diode. Current will only flow in one direction. So in the one cycle, current will be moving this direction. When current reverse, it will not be able to flow through the diode because it's in reverse biased. So you end up having one waveform, one wave is cancelled during when current is reversed. Then it has to wait again to change direction, then current will flow. So you realize that part of the waves are chopped off. So if the power output was, let's say 100 watts of alternating current, the average power, this alternating current or the mean power, it will be 50 watts. And when now that becomes 50 watts and we have lost another half of the wave, then it means we are going to have the mean power after the power remaining after the alternating current has been undergone this type of half wave rectification is going to be 25. So remember, power was 100, that is the alternating power. Then mean power now, usually it's a half of that value. But again, since it has lost, because if it will be a half, it will remain 50. And since it has lost these waves down here, it is going to remain to be 25. So half wave rectification is a type of rectification which uses one particular diode. So then now we are going to talk about full wave rectification. Full wave rectification is going to use 4 diodes, which are indicated at this point. So when current is moving in such a way that here we have positive and this point we have negative, D2 and D3 are going to be in forward biased. So current will flow from A to this point, flow through this because it's forward biased. Current will pass through the resistor. It will go back to this point. It will pass through D3, then it will go back, and that's going to make a full cycle. When now this point is negative and this is positive, then D1 and D4 are going to be forward biased. So you realize that when in one cycle, current will flow that way, and then it will end up making a half cycle. When current is going to reverse, then in that case, this will be negative and this is positive. Then current will flow from B through diode 4, then through the resistor back to this. Now that current is not going to go through this because at that given point D3 is in reverse biased. So current will flow through D1 back to point A. When A is positive, current will pass D2, go through the resistor, go back through D3, then back that way. When B is positive and A is negative, current will pass point B, go through diode 4, then it will go through the resistor, go that way. D3 will be in reverse bias, so current will not pass D3, it will go to D1 and then go back like that. So you realize that current is always flowing in the same direction in the load resistor, and in that case you realize that we are going to have an output wave that is behaving that way, and we end up having now a full wave rectification. But something that you need to remember, if the power of this alternate current was 50, the mean power of the output will be a half of that. Okay, so if the power was 50, mean power after rectification is going to be 25. But if it was 50 and it has undergone half wave rectification, then the mean power will be 25. Then again, it's going to lose that half because of this half, and it's going to be 12.5. So for half wave rectification is the original power times 1/4. For full wave rectification, the power that remains is a half times the original value. Well, there's something called smoothing. Smoothing is when, because you see after rectification, current will be increasing, come to 0. Then you see that now current will be, we are having direct current, but that direct current will be pulsating. It will be fluctuating from the maximum point to minimum point, then it will increase. So to avoid this from happening, we are going to include a capacitor such that when voltage is maximum, the capacitor will be charging. So when the capacitor charge, when current goes below, the capacitor is going to discharge, so that we can be able to reduce the ripples. Yeah, so the capacitor quickly charges up to the peak voltage, and when the rectified voltage is high, when the rectified voltage drops between the peak, then the capacitor is going to gradually discharge. In the process, it will be supplying the current to the resistor, so that we are going to have a bit small ripples like that. Yeah, so if you have found value from ProfLearn YouTube channel, consider subscribing so that anytime I'm going to be uploading more tutorials, you'll be notified. See you in the next tutorial.